Today we are going to learn how to solve quadratic equations by factoring. We've already learned how to factor, so really this will be very similar to some of the work we've already done. With solving by factoring, there are a few key steps you need to know. The first step is your problem always has to be equal to 0. If it's not set equal to 0, you can't solve by factoring. Second step is you have to actually factor it into your two parentheses. And we'll go back over how to factor. Third step is you have to take both of your factors and you have to set them equal to 0. So once you've set the right side of your equation equal to 0, so right side will be 0, the left side of your equation will be factored. You can take your factored expressions on the left side and set them both equal to 0 to solve. We're going to do some examples, but these are just your notes. So let's say you have a problem and it's already factored. So 5r plus 1, 8r minus 5. Lovely. So it's already set equal to 0, so step 1's done. It's already factored, so that's done. So the last thing you have to do is take your factors and set them equal to 0. And solve for r. The reason that we do this is because if one of these expressions right here is equal to 0, then your product is equal to 0. So we have to make sure that we solve for r, so we know what r has to be in order for this factor to be 0. So we would take away our lonely number, which is our 1, and then divide by our 5. So r equals negative 1/5, because that does not divide. The next one, you would add 5 over. 0 plus 5 is 5. Divide by our 8 and get 5/8. You can make these into decimals if you're more comfortable with that, but you can leave them as fractions as well. Sometimes we have problems that are not factored, but we're going to go over one more that's factored. Once again, this problem, x parentheses 3x minus 1, already set equal to 0, already factored. So you take your factors, which are x and 3x minus 1, and you set them both equal to 0 and solve. Lucky you, because that one's already solved for you. And this one, you can just add 1. 0 plus 1 is 1. Divide by your 3 to get x alone, which is 1/3. This works out because if x is 0, your answer is 0. If 3x minus 1 is 0, your answer is 0. We can get 3x minus 1 to be equal to 0 if x is 1/3. If you have a problem that is not factored but set equals 0, part of your work is still done for you. The problem is already set equal to 0, but it's not factored. Since there's no number in front, we're not going to divide by a GCF, so remember that you always look for GCF first. And since there's no number left in front, we don't have to slide it, so we'll cross that off our list. We can go right to our big X factoring. So we're finding what multiplies to 32 and adds to 12. If you make a list of factors of 32, this may help you. As soon as you get two numbers that add or subtract to 12, you want to try those in your big X and make sure that you can assign some signs that work for your problem. Since positive 8 times positive 4 is 32, and 8 plus 4 is 12, we know those are factors. Simply do your two parentheses with an r in each, because r times r is r squared. And 8 and 4 in your parentheses as well. If you need further help with regular factoring before we proceed, feel free to visit my other videos about factoring. After we have factored, which was our second step, was to factor, we can set them equal to 0. Since if one of these two factors is equal to 0, the whole product is equal to 0. We can solve this by simply taking away 8, solving our one-step equation, or taking away 4. This gives us our two r numbers to make these expressions equal to 0, which makes our answer possibly equal to 0. You may have a problem, such as this, that is not set equal to 0. I always like to keep the n squared positive, or whatever variable it is. If it's x squared, I keep the x squared positive no matter what. Typically this is done by moving everything to the left. It's like that Beyonce song, to the left, to the left. So if we're going to move everything to the left, and we want it to move over here, and we want it to cancel from the right side, it has to become positive, because the negative 6 and the positive 6 will get us 0. And what we do to one side, we have to do to the other. Since n squared and 6n are not like terms, we're just going to write n squared plus 6n. Try to follow the order that we talked about while factoring earlier, where you put the n squared first because it has the highest power, the n in the middle, and the constant at the end. And that's our quadratic template. When you look at this, you have it set equal to 0, so that's your first step. Your second step is to factor. Since it has two terms, not 3, we would always try GCF first, and then potentially try our difference of squares, where we take the square root of each. Since it's two terms and they both have a GCF, we can factor out the greatest common factor, which is n. We know that it's n1 because they both have an n, and whatever the smallest power of the letter is, that's your GCF. Divide them both by n1 and get your answer inside your parentheses. When they're stacked, you subtract. So it's n2 minus n1, which is n1, and 6n over n1 is either 6n0 or just 6. Our last step of this problem is to take our factors, because we've now factored this problem, and set them equal to 0. One is already done for you, beautiful. And the other one, you have to take away your lonely number 6. 0 take away 6 is negative 6. Let's do another one that's not set equal to 0, that has a few more things to move. When there's a lot of material, such as this problem, I just like to draw a line down the middle when I'm setting it equal to 0. So write down the equal sign, cut it in half. And I like to go ahead and do the opposite sign of everything that's on the right beneath it, just because that's how I know I'm going to get things to cancel. In algebra, the golden rule is whatever you do to one side, you do to the other. Since you're taking away 5x and 5x matches with 7x, I would put the negative 5x below the 7x. You're taking away 2x squared, which matches with 3x squared, so I do negative 2x squared. And lastly, you're doing positive 1, which is a constant, which goes with negative 16. I would put it below negative 16. This gets us equal to 0, which is our first step. We just have to add everything up. 3 minus 2, keep the label the same. 7 minus 5 is 2x, and negative 16 plus 1 is negative 15. Once it's set equal to 0, we can factor. Since it's 3 terms and there's no GCF, we can go ahead and go to the big X. So you would always want to look for a GCF first. If it was 2 terms, that's where you definitely do GCF or difference of squares. But since it's 3 terms, we can go to our big X. So numbers that multiply to negative 15, that add to 2. There's only 15 and 1, 3 and 5. So since 3 and 5 subtract to 2, we can put that in our parentheses, but we have to make sure the signs are right. One of them has to be negative to get a negative 15. If I make the 3 a negative, negative 3 plus 5 is positive 2. If I accidentally did it the wrong way, I could go back and double check and just change the negative around. Do your 2 parentheses with your negative 3 and your positive 5. You have factored. Now it's time to set them equal to 0. X would equal 3. And x would equal negative 5. We're going to try another solve by factoring, just because there's so many different types of factoring. Negative 4a squared minus 96 equals 4a minus 6a squared. Now, I know I told you that this should always be positive. And you're right if you're thinking, oh no, that's negative. You don't have to worry about this quite yet, because when we move stuff to the left, the a squared may very likely become positive. To set equal to 0, we do our opposite signs beneath to show that they're canceling to get us 0. Since 6a squared is the same as 4a squared, we can go ahead and we can do a positive 6a squared underneath the negative 4a squared, and a negative 4a can squeeze in there as well. Now when you're looking at this, negative 4a squared and 6a squared go together to get 2a squared. Negative 4a and negative 96 cannot go together because they're not like terms. So we put the negative 4a first, and the constant always goes at the end. It's set equal to 0, so we can go ahead and factor. You always look for a GCF first, so you would divide them all by 2. after you do GCF, if there's no number in front of the squared, we don't have to worry about the slide method that we talked about already. We can go ahead and just go right to the big X. On the ECA, you will not have to slide any problems that have equals 0 that you're solving. So we'll just focus on ones that do not involve sliding. This ends up being 8 and 6. And you need to have a -8 because that's the only way you're going to add